Welcome. This is a little homework help video for the first part of the probability homework, and that's just part one. So I'm going to give you some hints on all of these problems to help you out. M&M plain candies come in a variety of colors. According to the manufacturer, the color distribution is, and there we have that. Suppose you have a large bag of M&M candies and you reach in and take a candy out at random. Find the probability of orange candy or tan candy. Right? So, or, when we see or, we know to add. So you're going to take the probability of orange plus the probability of tan. Now, there's one other thing that we have to think of. If there's overlap, if there's candies that are both orange and tan, we would have to subtract the probability of anything that was both. If there's nothing that's in both categories, do you see any category that says orange and tan? Right? Well, I don't see one that's orange and tan. But if there was one, if a candy can be both orange and tan, then we would have to subtract that overlap. In this case, I will tell you that there's not. That kind of gives you a big hint on B. Are the events mutually exclusive? So if things are not mutually exclusive, there's overlap. It means no overlap. There's nothing in both categories. Another way to think of it is if it's mutually exclusive, and if A and B are mutually exclusive, then the probability of A and B, right? So the things that happen in both would be the null set. There'd be nothing in that overlap. I don't know why I put two P's in there. Right? So if events are mutually exclusive, there's no overlap. Right? If there's not mutually exclusive, there's overlap. And there are several questions that deal with mutually exclusive. Right? So besides just this one, are the events mutually exclusive? We have this one, and this one. And a little hint, if you get confused on number 2 and you can't figure out if they're mutually exclusive, you can use a deck of cards to help you. And look and see if there's any cards in both categories. All right, so that's just a little if you get confused. Let's look at number 3. Find the probability of drawing a king or queen from a standard deck of cards. So that, C. We didn't answer C. I kind of jumped down to number 2, right, because it kind of went along with 1A. Probability of not brown candy. Now, you can find the probability of the orange, the green, the red, the yellow, and the tan, or since not brown is everything but brown, you could use a complement. That's a little easier. Now, you wouldn't be wrong if you did it the other way, right? But that's supposed to say use a complement. Here, you know what? I'm going to write it over here, and I'm going to drag it over there, and then I'm going to show you, or remind you, what a complement is. And here we go. It's moving in right here somewhere. Here, I'll put it underneath. Right? So to use a complement, you would take, since everything added together would be 1, lost a C there, you would take 1, so the probability of not brown, I'm going to put not B because I'm running out of space, would be 1 minus the probability of brown. Right? So, here, so that you can actually read this, I'm going to move this up here, And I'm just going to label this C because I took up a little too much space. There we go. All right? So there's a little hint on C. You could use a complement, and it's a little easier. All right, now down to 3. Find the probability of drawing a king or queen from a standard deck of cards. Those are mutually exclusive events. You can't be a king and a queen together, right? So the probability of king or queen is the probability of king plus the probability of queen, and there are 52 cards in a deck. The probability for a driver's license applicant to pass the road test the first time is 5/6. The probability of passing the written test on the first attempt is 9/10. The probability of passing both tests the first time is 4/5. Are the events mutually exclusive? What's the probability of passing either test on the first attempt? All right, so mutually exclusive means that there is no overlap. That means that nobody who passed the written test on the first time passed the driver's test on the first time. Now you think about that. Think about yourself, right? You probably have already taken the driver's test, most of you, right? Did you pass it on the first time? Did you pass both of them on the first attempt? All right, so if they are mutually exclusive, if you say, yes, they are mutually exclusive, then the probability of passing either test means that's the probability of passing the road test and the written test. Right, so the probability of passing either test means the probability of the road plus the probability of the written. If you say they are not mutually exclusive, then that would be the probability of road plus probability of written minus the probability of road and written. And if they're mutually exclusive, there's no overlap. If they're not mutually exclusive, there's overlap, and you have to subtract out the overlap, or you've counted it twice. Find the probability of tossing 2 dice and showing at least 1 4. All right, so you're tossing 2 dice. There's a couple ways you could figure it out. You could figure out the probability of getting 1 4. You could figure out the probability of getting 4 on the other dice. You could add in the probability of getting 2 4s. Or another way you can do it is, since this is at least 1, right? That includes everything but no 4s, right? So at least 1 means everything but no 4s. So you could use a complement again. This is 2 dice, so you have to remember there's 36 outcomes for 2 dice. And I believe there's a chart in your notes, and you could look at, because that lists all of them. And if there's not a chart, it's on the lesson. And that lists all of the different possibilities, right? So you could do one of 2 things, and since you have the chart. You can do, so that's everything but no 4s. You could do, so the probability of at least 1 4 would be 1 minus the probability of no 4s. Or you can just count up how many of them have at least 1 4, and just remember 2 dice is 36 outcomes. So that little chart, since it's all labeled out for you and you can see all the outcomes that have at least 1 4, you could also use that. All right, and if it's not in your notes, it is in the lesson, and that is posted under, well, you know, I could probably move it into the COVID-19 folder. There you go. Moving along. This one is a Venn diagram. All right, so a little hint. Find the probability. This one is math and science. Find the probability of math and science first. And then don't forget to subtract. This value to find the math and science. So in other words, math is equal to all the math people minus the ones that are taking math and science, because you're going to count them twice. You're going to count them in the overlap, and if you count them again for math only, let's call that math only. You'll have counted them twice. The same thing, science only is all the science minus the probability of math and science, the ones in the overlap. And then probability of taking math or science or both just means the probability of math or, excuse me, not and. I'm saying or and I'm writing and. The probability of math or science, since both is covered in that, so long as you remember to count the both. And don't count them more than once, right? So you're going to take the probability of math plus the probability of science. These are not mutually exclusive. Don't forget to subtract off the ones that are in the overlap. Otherwise, you'll count them for the math, you'll count them for the science. Unless you count just math, just science, and both. So the other way you can think of it is probability of math only plus probability science only. I should just put S only. And then plus the overlap. Probability of not taking math, right? So that's the probability of, well, that would be the probability of science, anybody who's not math, right? So that'd be the probability of science only, or the probability of neither. Probability of taking math but not science, that'd be same thing. That would just be probability of science only. And probability of taking neither math nor science, that's the ones that aren't in the Venn diagram. So those are the probability of the neithers. They're not in the circles. All right, one last page. And by the way, you can pause this at any time and just kind of read through. And then this is the last ones in the notes. The probability that it will snow on Saturday is 0.25. The probability that it will snow on Sunday is 0.29. Find the probability that the probability that it will snow on both days is 12%. I don't know why I read decimals for the other ones. What's the probability it will snow Saturday or Sunday? They're telling you that these are not mutually exclusive. Right? If they were mutually exclusive, they're, well, that is not 0.25 times 0.29. So they're not mutually exclusive. Or means to add. Right? And then don't forget to subtract the overlap. The probability that it snows on both days. Of 100 students, 27 are taking calculus, 36 are taking French, 13 of which are taking both calculus and French. If a student is picked at random, what is the probability the student is taking calculus or French? All right, again, we have students that are taking both calculus and French. They are clearly telling you these are not mutually exclusive, right? Not mutually exclusive. Or means add. And again, don't forget to subtract the probability of the French and calculus, the ones that are taking both. At a particular school with 200 male students, 58 play football, 40 play basketball, and 8 play both. Find the probability that a selected male student plays both basketball or football. Find the probability that a randomly selected male student plays either sport. I said make a table first, and you could. You could make a table, but here, let me tell you what I think might be even better. So I'm going to have you cross that out. Make a Venn diagram instead. I think that would be even easier. I said table, but I think Venn diagram would be best. All right, so that you can have this be football and this be basketball, and of course that's the center there is the both, and then here you would have the people that don't fit into either category. All right, so I think that was the last one. If there's nothing else, there was nothing else. So that was the last problem from the first part. I hope that helps you out. Bye for now.